All right. Hi, everybody. Yay! Day 12 of distance learning. So today we're going to talk about one of my favorite topics. We should spend the whole year just talking about this, vaccines and how they work. And right now with everything kind of going on, if you've watched the news, I'm sure, some of you are hearing all these different things regarding COVID-19 and trying to find vaccine. We're going to actually talk about the science behind vaccines in general. So a lot of this will be applicable to what's going on around us now. So May 21st, 2020, let's get into it. So by the end of today, you should be able to differentiate between antigens and antibodies. I'm hoping you can already have a glimpse as to that from the last lesson as well. Explain how vaccines strengthen your immune system. Talk about the role and purpose of specific types of vaccines, and I'll share some information with you on vaccines in California. It's interesting stuff, and you can look at it later on your own. And identify the main attributes of the immune system overall and in general. So just a recap of where we should have been. Antigens are specific ID badges, right? There's outside markers on all of our cells, so we know that our cells in our body are supposed to be there. They're good. They're not foreign invaders, okay? Fever is an important part of the inflammatory response, we said, because it's going to kill those foreign particles. It also speeds up that process of phagocytosis, where we're invading, where we're eating and engulfing those foreign bacteria and particles and breaking them down. And acquired or active immunity improves with exposure to different pathogens, right? So your immune system's getting stronger as you age, and we'll talk about why that occurs. So when we look at lymphocytes, there's two types. We could talk about B cells and T cells, okay? And I kind of just showed you on the right side the difference of where they can develop, right? T cells coming from the thymus, hence the T, right? B cells coming from bone marrow, right? So hence the B. All right, so we got that. So we know that B cells are going to mature in the bone marrow, as I previously said, and it's going to deal with the humoral response. That's a fancy way of saying any body fluids, okay? And these are what we're focusing on primarily with antibody production, okay? T cells, again, are going to result from the thymus. There's a cellular response. So the T cells are going to help us to distinguish self from non-self cells, meaning self cell, good, non-self, you're not supposed to be here, you're going to get me sick. All right, so looking at B cells a little bit more, we know that this is in the fluid, okay? They're going to circulate through the blood and the lymphatic system, so they're going to go into all parts of your body. They're specific targeted response. They're looking for specific things. So they're going to make specific antibodies to an antigen. So if it's the first time that my body is getting exposed to a unique bacteria, virus, some sort of pathogen that I've never been exposed to, I don't have immunity against that. I don't have the antibodies build up because this is my initial or first exposure, and that will make a little bit more sense as we go on. Plasma cells help with this quick short-term release. Memory cells keep the memory, they're more long-term. So they kind of keep a picture book, let's say, of all of these foreign invaders we've killed. So what happens if your immune system gets it wrong? I had this question happen a lot, like, hey, what if my immune system starts to attack my healthy cells? Then it results in something called an autoimmune disorder or disease, okay? And basically, it can look different in different people. Sometimes there's genetic factors that play a part. Sometimes these things have to do with hormones and change in the hormone production levels. There's a bunch of different things that can cause this. So as you see in the image on the right side, I kind of gave you a couple, not a lot because there's a lot more, autoimmune diseases and disorders that can occur. Not all of these are life-threatening. It doesn't mean that you're going to just die, right? But some of them do manifest in different ways. So like rheumatoid arthritis, that's going to affect your bones. Lupus, again, is going to impact your body system and immune system as well. Multiple sclerosis is a little bit more serious. Type 1 diabetes with medication and lifestyle changes is totally manageable now, but definitely it's something that you're gonna have to deal with. So again, I don't want you to think an immune disorder or disease is life-ending. It's just you might have to change some things or just do some different treatments. Okay, so let's talk about antibodies specifically. So a lot of times I have people say, okay, I know the yellow thing, this thing over here is a cell, this maroon thing in the center is meant to be a nucleus, and there's these Y's on the outside. Why did you put Y? Why not put the letter Q, miss? It's not a letter Y. It's meant to represent an antibody on the outside because this is actually how antibodies look if we were to create a drawing of them. Okay, so an antibody is going to bind to a specific antigen. Remember, it's kind of like a lock and key. It's going to fit into a specific one. So if I'm the antibody for If I'm looking for, let's say, the varicella antigen or the chickenpox antigen, I'm only looking for chickenpox. There could be 100 bacterias and diseases coming by. I'm not getting them. I'm only looking for chickenpox. So kind of keep that in mind. They are specific. It's going to match them. Again, think of lock and key, and it's kind of like a handcuff, right? Like it's grabbing them, guarding them, and then we're going to make sure that they get destroyed. Okay, and that's just the binding site on those, just so you kind of know that the little arms of the Y are binding with them. Again, this is just showing you the actual structure. Do I need you to memorize this? No, I'm just reminding you that these are proteins, and these are really kind of cool, in my opinion. All right, so how do these antibodies work? So these antibodies are going to grab that foreign pathogen, and we're going to cause something called agglutination. So when you look over here, you see this word agglutination. It sounds like glue. So think of the antigen and the antibody gluing together, and they're going to get really clumpy. And what that does is it's going to trigger some other like macrophages and things like that and phagocytes to come over and do phagocytosis and break it down, okay? If that doesn't occur, the other thing that can happen is you could also get it where the antibodies inject this thing and cause the cell to lysis or explode, which also breaks down all the materials on the inside as well. So something to kind of think about. Again, that idea of phagocytosis and those macrophages being able to engulf those foreign invaders and take them in, super important. All right, here's the bottom line with this slide. There's a bunch of different types of antibodies and immunoglobulins. We're not going to get into all of them, but here's what I did want to show you. If we look at this graph over here, okay, your antibody levels, if they're increasing, right, and this is time. So if we get exposed to an antigen over here, we get a first response. We get these antibodies built up, okay? Now, over time, you're gonna build more. So your first response gives you some antibodies. Your second response is going to give you more, okay? So it's going to increase, and I'll come back to that a little bit later, okay? So let's talk about the B cell, how it works. So foreign invader comes in, not supposed to be there, foreign antigen, not good. So your B cells with those antibodies, they're going to get wind of this. They're going to know. They're going to start to recognize and be like, hey, this isn't supposed to be here. From there, they're going to make a bunch of copies of those antibodies because they're going to be like, we need to rev up and get our army because this thing is trying to attack us and kill us, right? And so then we'll have a bunch of those clones release those antibodies, capture those invaders, okay? And we'll also have some of those antibodies just hanging out on the side for our memory cells, right? To have in reserves just in case we don't get this guy on the first time. That's kind of how the B cell response works. Okay, now do you need to know all this in detail? No, I'm just kind of giving you a step-by-step about how this works. Again, it's about 10 to 17 days for a full response. This can vary based on the invaders, but again, this is just in general what we see. All right, so first response to second response of disease. So let's pretend your first exposure is over here. This is time. Let's say it's day 1, okay? So you're going to get these antibodies built, okay? Then let's say it breaks. Your second response, if you get exposed again to antigen A, is going to be higher this time because it thinks to, well, because your immune system, it doesn't think on its own, but it's kind of like, hey, I got exposed to this once, I got exposed to this twice. This must be really common. I need to get really strong and make sure I'm ready to fight this thing, right? That's kind of what it's doing. So I just wanted to kind of give you that. That's not a lot, but there's some antibodies production. We get the most antibody production in the second wave, and we also get some antibodies to antigen B if we're also exposed with that as well. Okay, so vaccinations. Vaccinations are going to have a dead or weakened, inactive form of a virus, right, of a pathogen, okay? And this, in a safe way, triggers active immunity. So it's like you're getting exposed to this virus or this specific pathogen in a safe way so that it will not actually cause you to get that. Okay, it stimulates your immune system to produce those antibodies and to get those antibodies and those memory cells prepped, just in case you actually do get exposed to the real deal, right? And if you do get exposed to the real deal in the future, we know that it's going to be stronger. You're going to have a strong immune response because you're going to have more antibodies built up. Okay, so let's talk about Jonas Salk. So he developed the first vaccine, and it was against polio, and polio was really debilitating, and I'll show you some pictures in the next slide. And what it would basically cause is children would go to bed fine, they'd wake up, and they'd lose complete motor function of their legs. So they would have a difficult time with that. A few things. Jonas Salk, when he developed this vaccine, he gave it away for the total cost of $0 and made sure that everyone got that and they were healthy and ready to go and they were building up that immunity. His was an injected version. Sabin, so if you can see over here, Sabin in 1962 came up with an oral vaccine. Now, the difference between the Salk vaccine and the Sabin vaccine, the Salk vaccine was a dead version of polio and had to be injected, which means you would have to get a booster shot to continue that immunity. With Sabin's, it was actually a weakened version of that, and so you would just not have to boost it as often. It would last longer. Okay, just to kind of give you an idea. So here's some pictures from the polio epidemic, and you can kind of see how it was impacting life and children. And this is kind of a big thing. These were potentially treatment chambers. Those chambers were treatment chambers that they thought. By 1994, the Americas were polio free. So that kind of gives you the importance and significance of that vaccine. Okay, so I'm going to get back to vaccines in a second, but 4 key things about the immune system that I want you to take away from this. The immune system is specific, so you should know about antigens and antibodies, how they relate to each other, that kind of lock and key. It's diverse, reacts to a bunch of antigens. It has a memory, so it's able to respond quickly the second time it gets exposed to a pathogen or foreign antigen. And it's the ability to distinguish self and non-self cells, right? And so this is just something to kind of think about as we look at this. I also wanted to show you one thing here that I thought was kind of cool. So you can look this up on the CDC's website, but basically what this is this is the schedule that the CDC recommends for vaccines. So you can kind of go through here. So hepatitis A, B, right? And it gives you the abbreviation. So DTaP, all of you have this because you have to have it. You actually have to show that as part of your registration at Lakeview. And it goes through some other ones. Then if you want to see when you take it, this gives you like, hey, at birth, they're going to offer you hepatitis B. Right? The second dose of that you should have around this time. And it kind of goes through the schedule. Now, why does it have this schedule? Remember, why, if you're like, well, if I took Hep B at birth, why do I need to get it at, I don't know, 6 months? Because you're building up those antibodies. Remember, your first exposure is going to give you some antibodies. Your second exposure is going to give you a lot more. Your third exposure. So we want to increase the amount of antibodies you have to guarantee that if you do get exposed to hepatitis B or something like that, I'm just using that as the example, that you will not actually contract hepatitis B. Your immune system has been developed enough so that you'll have the things that you need, the tools that you need to fight that off. Okay. It also talks about influenza and the annual vaccine, which is kind of important there. It also talks about HPV. And there's some information over here. So, you know, that's just something that I thought was kind of cool. You know that I'm kind of a nerd and I like those things. So anyways, I hope this has been helpful to you. Have a great rest of your day.